All right, class. 2.6, day 1, prove statements about segments and angles. So what is a proof? A proof is a logical argument that shows a statement is true. A logical argument that shows a statement is true. Then a two-column proof is a way that we'll commonly write these proofs out with two columns. Statements on one side, reasons on the other. And that's a proof with numbered statements and corresponding reasons that show an argument in a logical order. So we would be breaking down every step, each step with its corresponding reason. Each step with its corresponding reason. And have them in two columns, one statement column and one reason column. So our reasons that we will use in proofs are on the last 2 pages of the Unit 1 or the Unit 2 note packet. The last 2 pages of the Unit 2 note packet have a page of Unit 1 definitions and a page of Unit 2 definitions, or the postulates and properties. Those are what we're going to be using. Definition of a theorem is a statement that can be proven. A statement that can be proven. So here is what a standard two-column proof will look like. You'll have a given statement. It'll say given, and it'll give some information. It might be AB equals CD. That might be given to you. And that would be kind of your starting point, this information that you know. There will also be a drawing, and drawings can also give given information. So sometimes there may not be anything written as given, but they might give you a drawing, and the drawing might show the different line segments or angles are congruent. That would be given information. That's information that they're giving you, that the problem is giving you. And then there's also something that we want to prove. Prove or show is what we would read or hear. And that's going to be at the end. So we have to get from, generally what we're getting from is our given statement to our proven statement. Sometimes given can be in a little bit different order, or if they give us 2 or 3 given statements, we might not start off with both of those. There might do a given statement, then something else, then a given statement, and then keep going. But generally the given statements are first. Generally they come first as our statements and reasons. So let's look at example number 1. Here we have a diagram, and in the diagram we see that AB is equal to CD. We see those little tick marks in the diagram, so if they didn't write that off for us, if they didn't write that out for us on the left, we still have that diagram telling us that AB is equal to CD with those little congruent tick marks. And we need to show that AC equals BD. So we're proving AC equals BD. And if we look all the way down at the bottom of our proof, we have AC equals BD. That's what we're trying to get to, or we're trying to prove. So let's look at our statements and reasons section. So we have AB equals CD. Well, that's what they told us at the beginning. That is our given statement. Given statement. We already know that. Then we have AC equals AB plus BC. So let's look at what that is. We're saying that AC equals AB plus BC. So what is it whenever we know we have two smaller line segments adding together to get a bigger line segment? What is that called? That is the segment addition postulate. And you would find that on those last 2 pages of your Unit 2 notes. That's under the Unit 1 postulates and theorems that are used in proofs. So it's on that first of those last 2 pages. So those last 2 pages are going to be where you're going to find the reasons that we use. Next we have BD equals BC plus CD. So let's look at those. We have BD, and it says that BD is BC plus equal to BC plus CD. So again, we're adding 2 smaller segments to equal a larger statement. So that's the same segment addition postulate. So we have the same reason for that one. Our next statement says AB plus BC equals CD plus BC. Now that's, if we look at, it's nice in this example, we have the plus BC highlighted for us, so that should give us a clue as to what's going on. But if we notice, back to our given statement, we have AB equals CD. Well, if we look at that diagram, if we're saying we're adding BC to each of those, that's just that middle segment there. We know the 2 on the end, AB and CD, equal each other, and we're just adding BC to each of them and saying that they still equal one another. So, but looking at your reason page, what reason has you adding the same thing to both sides of an equal sign? That's the addition property. Addition property. And then we have our last statement, AC equals BD. How do we get to AC equals BD from the previous statement, from AB plus BC equals CD plus BC? Well, if we look at AB plus BC, where else do we see AB plus BC in our statements? We see it up there. AB plus BC is equal to AC. So we are substituting AC for AB plus BC. And then CD plus BC, we also see that right here. And that's equal to BD. So we're taking BD and substituting it in for CD plus BC. So that is substitution. Substitution. And then there we have proven that AC equals BD. Example number 2. We need to show or prove that CF equals AD. So we know that's what we're trying to get to at the end. CF equals AD. And if we go down to the bottom, we actually don't see what that proven statement needs to be, but we're told what it is at the top. So we can actually fill that in It's CF equals AD. So sometimes with these proofs, you know what the beginning is, and you know what the end is, and you've got to fill in all of the gaps in between, right? Sometimes you can work up a little bit from the bottom. Maybe you can't work all the way up from the bottom. Maybe it's just too complicated, but sometimes you can fill in some stuff at the bottom too. But let's go back up to the top, just letting you know that that's a possibility. Back up to the top, and our given information is here in the diagram. We don't have any written down word for word given information, but we do have this diagram that shows us some different segments are congruent with one another or equal to one another. So AB equals what? Well, here's AB. The other mark, or the other segment with a single congruent tick mark, is EF. So we know AB equals EF, and that's given. If we look at BC, BC has 2 tick marks. The other segment with 2 tick marks is DE. So BC equals DE. That's also given. Next we have AC equals AB plus BC. So let's look at that. We're talking about AC equals AB plus BC. So that's 2 smaller segments added together to give us a larger segment. So that is the segment addition postulate. Our next statement, we need to fill in a blank. DF equals blank plus blank. And we know it's the segment addition postulate, so we know it's going to be similar to the one we just did. So let's look there. We see that DF equals something. DF needs to equal 2 smaller segments adding together. So it equals DE plus EF. DE plus EF equals DF. That's the segment addition postulate. The next one, DF equals BC plus AB. Now be careful here. The statement looks like it should be segment addition postulate, right? Because it's written the same way. But if we look up at our diagram, now we're saying that DF equals BC plus AB. How did we get over there? If we notice, DE is also equal to, we'll use the same color to match up, DE is also equal to BC. So we've taken DE and substituted in BC. So we've taken BC and substituted it in down there. And then we also see EF is equal to AB. So we would take that and substitute it in for EF. So there we have BC and AB, and we got that by substituting in AB for EF and BC for DE. So that's the substitution property. substitution property. Then we need to get from that to df equals something. Well, if we know df equals bc plus ab, and we know bc plus ab equals, where else is there bc plus ab or ab plus bc? Right up here. And it equals ac. So we're saying df equals bc plus ab, and bc plus ab equals ac, then df equals ac. So that should be our blank there. Now what is it, what property is it when you say if one thing, or say, let's just use numbers here, if 1 equals 2, or if x equals y and y equals z, then x equals z. Or if a equals b and b equals c, then a equals c. That's what we're saying. That's the transitive property. Transitive property. Okay, so let's scroll down the rest of this. We have df plus cd equals blank plus cd. Well, all we've done is add cd on both sides. If we're adding cd on both sides, what does this blank still need to be? It needs to be AC. And if we add the same thing on both sides, what is that? That's the addition property. And we already filled in our last two blanks, what we were trying to show, what we were trying to prove, that CF equals AD by the segment addition postulate. So to get CF equals AD from what we have, looking back up at the top, we had CF, and we want that to equal AD. To get that, we added DF and CD. There was DF and CD to get that larger segment. And we also added AC and CD. AC and CD to get that larger segment. So we were using that addition, or the segment addition postulate, adding the two smaller segments to get the larger segment. We just did that twice in the same step. Example number 3, 4 steps of a proof are shown. We need to give the reasons for the last 2 steps. So we even have 2 of the steps shown, or 2 of the reasons shown for us. So our given statement is AC equals AB plus AB. AC equals AB plus AB. That's just what's given. I wonder if that should be AB plus BC. We'll see as we go. So we know that that's given. It's written again the same way, AB plus AB. Then we see number 2, AB plus BC equals AC is the segment addition postulate that's stating that AB plus BC equals that larger segment. That is the segment addition postulate. Then we see number 3, AB plus AB. So I guess we're sticking with that. AB plus AB equals AB plus BC. So how can we get from what we're shown in our given statement and our segment addition postulate, AB plus AB equals AB plus BC? Well, we see that AC right there equals AB plus AB. So we can say that we've substituted AC with AB plus AB. And that went in here. And we can see that AB plus BC AB plus BC is also shows up there. And AB plus BC equals AC. So it just stays there. So we just switch the sides of it, of the equal sign, but we substituted AB plus AB in for AC. So that's the substitution property. It could also be transitive. You're going to see a lot that transitive and substitution can be used in the same reason. And that would be that AB plus BC equals AC and AC equals AB plus AB, then AB plus AB equals AB plus BC. So it's transitive and it's substitution. Transitive or substitution. And you would only need to give one of those reasons. And then our final statement is what we needed to prove, AB equals BC. So we're trying to prove that those two statements are equal with one another. How do we get to AB equals BC from number 3? Well, we've got AB plus AB equals AB plus BC, and we want to get to just 1AB equals BC. Well, if we subtract AB on both sides, that's going to cancel out those ABs, and we'll be left with AB equals BC. So that was the subtraction property. So we had to subtract the same thing on both sides. We had to subtract AB on both sides to get to AB equals BC. All right, example number 4. For this one, I want you to pause and try and figure out those reasons on your own, and then unpause and we'll go over the results. Okay, hopefully you took the time to try this on your own, but let's look at this. Number 1, M is the midpoint of segment AB. Well, that's our given statement. M is the midpoint of segment AB. So I write given as reason number 1. Then we have segment AM is congruent to segment MB. Well, if we look at, and I actually want to pull this up back at our definitions page, if we look at the definition of midpoint, it says if M is the midpoint, then AM equals MB. So we're going from knowing that M is the midpoint to do two things, those two segments being equal. So this is our definition of a midpoint. Definition of a midpoint. So we know that those are congruent now. Then number 3 looks very similar, and so we're going to go back and look at that definition page again, but we have, how do we get from segment AM congruent to segment MB to AM equals MB? And look at that definition page, and over here on definition of congruent segments at the top, we see two segments congruent to each other, then they have the same length. So that segment AB is congruent to segment CD, means that AB equals CD. It's two segments who have the same length. So that's a definition of congruent segments. Definition of congruent segments. Next we have AM plus MB equals AB. So we're looking at AM plus MB equals AB. So we have two smaller segments adding together to get a bigger segment. That is segment addition postulate. Next we have AM plus AM equals AB. So if we look at specifically number 5 and number 4, what changed to get from number 4 to number 5? The only thing that's different is that second thing that we're adding, MB and AM. Well, we know AM equals MB from right there. So we're able to substitute AM in for MB. So we just did the substitution property. Substitution property. So now going from number 5 to number 6, how did we get from AM plus AM equals AB to 2 times AM equals AB? We combined our like terms. AM plus AM combined is 2 times AM. So we just simplified. We combined our like terms. So simplify is the reason there. And there we've proven how to get from knowing that M is the midpoint of segment AB to 2 times the segment AM equals the segment AB. That's it for the notes.